Okay, we'll go to the next lesson. So, okay, look up. So, we are on to the next chapter now. Trigonometry. Yeah. Okay. So firstly, as you know, we measure angles using degrees. So this here is 360 degrees. But a new way, or a different way, of measuring angles is by using something called radians. And radians are useful because, for example, here, this is 45 degrees, okay? Whereas when we use radians, what we're actually measuring is this distance here. So, if I just draw that again a little bit bigger, when this is 1 unit, and this is 1 unit, and this is 1 unit, then what we say is we call this angle here 1 radian. Or another way to think about it, when you have 1 full circle, that's called 2 pi radians. So you can think of the relationship like this: 360 degrees is the same as 2 pi radians. Or if you want, 360 is roughly 6.2830 radians. So radians are quite a big unit for measurement. So now, how can I switch between degrees and radians, or radians and degrees? So if I want to go from degrees to radians, I multiply my number by pi over 180. And if I want to go from radians to degrees, I multiply by 180 over pi. So this is how I can convert. So let's have a look at some examples. So for example, if I want 33 degrees in radians, then I just do 33 multiply pi over 180. So if you type that in on your calculator, what do you get? Yeah, and as a decimal? Okay, radians. Now let's look at one the other direction. I want 8 pi over 15 radians in degrees. So I would do 8 pi over 15 multiplied by 180 over pi. What's that now? They cancel. That goes in there. 10, 12 times 80 times 96? 96, yeah? 96 degrees. Yeah? Okay. Please note, if I write this, that's 4 degrees. And if I write this without the degree symbol, that's 4 radians. It's a common mistake in the exam, so please be careful. This is degrees, and then when absent it is radians. Okay. Now time for some revision of elementary school. So, you're back in elementary school, teacher's drawing you a triangle, and you hear a name, Pythagoras. Yes, Pythagoras, a squared plus b squared equals c squared. And this is true for all right angle triangles. A squared plus b squared equals c squared. So, some examples. If I scroll down. This is 3, this is 4, and I want this side. So you have 3 squared plus 4 squared equals x squared. So 25 equals x squared. So x is 5. Here's another example. 5x 13. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. X squared equals 144. X equals 12. Okay, now I'm going to talk a little bit about sine, cos and tan. Okay, so if I scroll down, this here is angle A. This side here is called the opposite. This one here is called the adjacent. And then this one here, hypotenuse. Or just O, A, and H for short. Now if you look at this triangle, there are 9 ways you can compare the sides. So for example, you could compare opposite with adjacent, opposite with hypotenuse, opposite with opposite, adjacent with opposite, adjacent with adjacent, adjacent with hypotenuse. You can also compare, actually hang on, how many do I have? Maybe if I put it in a table it'd be a little bit easier. So you have opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse, yeah. Now these ones here don't make any sense. Opposite with opposite is always 1. Adjacent with adjacent is always 1. And hypotenuse with hypotenuse is always 1. But you could compare opposite and adjacent. So that would be opposite over adjacent. You could compare opposite with hypotenuse. That's opposite over hypotenuse. Adjacent with opposite. Adjacent with adjacent, no good. Adjacent with hypotenuse. hypotenuse with opposite, and hypotenuse with adjacent. Now, of these 6 in blue, 3 of them we'll study in semester 1 and 3 of them we'll study in semester 2. So in semester 1 we'll look at this one here, and this one here. And then these 3 in red, we'll look at those in semester 2. So the 3 fractions in blue, in green I mean, they have special names. When you compare the opposite with the hypotenuse, that's called the sine of angle A. And when you compare the adjacent with the hypotenuse, that's called the cosine of angle A. And when you compare the opposite with the adjacent, that's called the tangent of angle A. So for example, with this triangle here, that's 3, 4 and 5, and that's angle A, I can say sine of A is opposite over hypotenuse. Cos of A is adjacent over hypotenuse. And tan of A is opposite over adjacent. And by the way, if I put my angle up here instead, it's nearly the same thing, except the opposite and adjacent swap places. So now this one's the opposite. So sine of B will be 4 over 5. Cos of B is 3 over 5. And then tan of B will be 4 over 3. Okay. Can I scroll that? Not yet? I can scroll down. So, let's have a look at some examples here. So scrolling down, let me draw this triangle for you. So this is 90, this is 1 and this is 1. So from Pythagoras, how big is the hypotenuse? Square root 2. Okay. Now notice, these 3 angles, what must they total? 180. Yep. So if this angle is 90, then how much must these 2 be? 90. And because this is 1 and 1, this triangle then will have angles here that are the same. So then these must both be 45. What's the name of a triangle that has 2 sides the same? Bilingual? What is it? Isosceles triangle, yeah. Don't worry, I think that vocabulary is later in the chapter. Bilingual I like though. Okay, so if I look at this triangle, what's the sine of 45? So what's the sine of 45 here? 1 over root 2. And then cos 45 is 1 over root 2. And then tan 45, 1. Now if you take out your calculator, type in, for example, tan 45. Tan 45, yeah. And you do get 1. So this is useful, because these sine, cos, tan functions are built into the calculator. And let me draw you another triangle. Okay? Next triangle, I have to do it in 2 parts. What's the name of the triangle with the sides all the same? Equilateral. So this is 2, 2, and 2. And then what are these angles? 60, 60, and 60. So this is 60. This is 60. Now if I draw a straight line down here, then this here is 90, and then this one here, 30. Yeah? And then how big is this side now? It's not 2 anymore. How big is this? It's 1. And this is still 2. And from Pythagoras, we can get this to be square root 3 from Pythagoras. So if I look at this triangle, what's the sine of 60? Root 3 over 2. Now type in sine 60 on your calculator and see what you get. Root 3 over 2. What's cos 60? 1 over 2. And then tan 60? Root 3. Sine 30, I can see is 1 over 2. Cos 30, I can see is root 3 over 2. And then finally, tan 30 is 1 over root 3. No? It's the same thing as 1 over root 3. 1 over root 3, multiply the top and bottom by root 3, that's root 3 over 3. What's the name from our chapter on surds for when you take the square root, when you remove the square root from the denominator? What's that called? Yeah, that's called the conjugate, but what's the name of the process? Rationalizing the denominator, or as you said, you multiply the top and bottom by the conjugate. Okay, so let's look at some examples using sine and cos to find missing sides. So if I draw this triangle, and I tell you that this is 289, this is 34, this is 56, and I want x here. So which should I use? Sine, cos, or tan? What do you think? I could use sine or cos, because you could say sine 34 equals x over 289. So then that means x equals 289 sine 34. So what's that, please? X equals 1. So 162 about. Let's do one where we have to find the angle now. So if I scroll down, so this side here is 140, this is 171, and this is x. So sine, cos, or tan? Which should I use? Tan, because I have the opposite and the adjacent. So you have tan x equals 171 over 140. Now this is something new I'm going to show you. Yeah, inverse tan. So what you have here is, you want to know what the x is. You want to know tan of what equals 171 over 140. So we use a function on our calculator called tan inverse, yes, or I think it's the second function, tan button on the calculator. This will tell you what the x must be. X equals tan inverse 171 over 140. So the calculator can tell you what the x must be so that the tan of it is 171 over 140. And you can ask the calculator for the angle by typing this in. So what is that? 51 about. Yeah. Okay, scrolling down. You don't always need your calculator. For example, if I ask you to calculate sine cos inverse 4 over 5, this here is an angle, and this is the sine of an angle. So you could type this in on your calculator, but you don't need to, because if you look at it like this, cos is adjacent over hypotenuse. So this angle here is from the triangle with adjacent 4 and hypotenuse 5. So what's the opposite here? 3. So this here is that angle. So if I want the sine of that angle, what's the sine here? Yeah, so the answer is 3 over 5. Now if you type this in on the calculator, you should get 3 over 5. We can check it. Yeah. Yeah. We don't. What do you mean multiply? It's like sine of this number. But what I'm saying is I don't need to use my calculator. What I can do is I can draw this triangle and then get the sine of this triangle, which is 3 over 5. So this here, sine inverse, cos inverse, tan inverse, what do they give you? They give the angle. So if you have a sine cos tan inverse, then you have an angle. And I just want to say that if you look at American websites or American textbooks, they don't use sine cos tan inverse. They use something called arc sine, or just a sine. That means this, the same meaning, okay? So you have arc cos, or a cos, and then you have arc tan, or a tan. And they mean the same thing, okay? So if you're looking at an American textbook, or American video, or website, they will use a sine, a cos, a tan, to mean sine inverse, cos inverse, tan inverse. Or in other words, the angles. Okay. Did anybody use these in high school instead of the sine cos tan inverse? No. What about my American educated students? You said you have no, not this. Really? All right. Okay. Anyways, I'll use this one then. Fine. That's somebody. There's always one. Okay. So. What I'd like you to do is the last 4 in each. So the last 4 in each. You can start them now.